Hi, in this lecture, I would like to share something about the Hamming code. Before starting this lecture, why you are concentrating on the Hamming code? What is the necessity of the Hamming code? The data can be transferred from one place to another. It is in a form of digit. In some time, data can be corrupted during the transmission process. How to provide the reliable communication in a network? Error can be detected and corrected during the transmission in a receiver side. Error detection and corrections are implemented either in a data link layer or in a transport layer of the OSI model. This error can be classified into three types. The first one is the single bit error. The next one is the multi-bit error. Next one is the burst error. In a single bit error, only one bit can be changed during the transmission. This is the sender data. This is the receiver data. This bit only to be changed for the transmission. This is called single bit error. Multi-bit error, one or more non-consecutive bit within a given data string. This is called the multi-bit error. This is the example of the multi-bit error. This is the transmitted data. This is the receiver data. During the transmission, this bit and this bit can be changed. Burst error. It is a burst error when a two or more consecutive bit within a given data string. It can be affect one or more character within a message. This is the example of the burst error. This is the sender data string. This is the receiver's data string. The burst of bit can be changed during the transmission process. Next, we are going to see about the error control coding. In a error correction technique, there are several types of the one of the type is forward error correction. In this method, errors are detected and corrected by proper coding technique at the receiver end. How to detect this error or how to correct this error? The check bits or redundant bits are to be used in a receiver side or to detect and correct the error. How to add the check bits? In a transmitted side, only the check bits and redundant bit to be added. The error detection technique and correction capability of the receiver depends upon the number of redundant bits in a transmitted message. It is a faster, but overall probability of the error detection is higher. One of the forward error correction technique is the Hamming code. It can detect the single bit of error. In this Hamming code, the redundant bit to be added in a transmitter side. How to find the redundant bit? By using this combination 2 power r greater than or equal to m plus r plus 1. This condition can be satisfied for the redundant bit. Here is r is mentioned as the redundant bit. This m is mentioned as the data bits. The total message can be sent from transmitter to receiver is m plus r. This redundant bit is also called as the Hamming bit. This is a Hamming code. This total bit can be transmitted to the transmitter to receiver is the m plus r. This m is our data bit, r is the redundant bit or Hamming bit to be added in any position of the data string. How much Hamming bits to be required? That means how much r to be included in this data string. This condition is used for this finding the Hamming bits. 2 power r greater than or equal to m plus r plus 1. First, we are going to substitute. The value becomes 3. If you substitute the value of 3 means 2 power 3 is equal to 8. This is greater than or equal to. Now, here we are choosing the ASCII representation. That's why the number of bits becomes 7. This becomes 7 plus 3 plus 1. What is the answer for this one? 8 greater than or equal to 11. This condition is satisfied or not? No. Then we are going to substitute the value of 2 power 4. That means r equal to 4. 2 power 4 is equal to 16 greater than or equal to 7 is the ASCII bit we are choosing here plus 4 plus 1. Here 7 plus 4 is 11. 11 plus 1 is 12. 16 greater than or equal to 12. That's why this condition is satisfied. In this ASCII representation, that means we are choosing the data bit becomes 7 means our redundant bit value becomes 4. 4 number of bits to be included in this data string. How to finding the position of the Hamming bits. First, 2 power 0 is equal to 1. Then 2 power 1 is equal to 2. Then 2 power 2 is equal to 4. And 2 power 3 is equal to 8. As like it, they are going to find the Hamming bit position. The first position, the redundant bit. The second position is the redundant bit. The fourth position is the redundant bit. And eighth position is also a redundant bit. Other places are the data bit. Then how to finding the value of the Hamming bits? This is a one type. Here first we are going to find the R1 value. Here there are totally 11 positions are there. That's why we are choosing from 0 to 11. Okay. The first we are going to find the R1 value. The R1 value, where the number of 1 in this column, the corresponding decimal value to be noted here 1, 3, 5, 7, 9, 11. We are going to find the XOR operation. R1 is equal to XOR of 1, 3, 5, 7, 9, 11. As like that, we are going to find the R2 value in this R2 value, this one, this one, this one, this one, this one, this one. These are the position of the R2 has the number is becomes 1. The corresponding decimal value becomes 2, 3, 6, 7, 10, 11. That's why R2 is equal to XOR of 2, 3, 6, 7, 10, 11. As like that, we are going to find the R4 value. This R4 value, 1, the position of 4 and position of 5, position of 6 and position of 7 containing the number of ones. That's why R4 is equal to XOR of 4, 5, 6, 7. As like that, we are going to find the R8 value. The R8 value becomes R8 is equal to XOR of 8, 9, 10, 11 because of this position is only containing the ones value. Then how to find the R1 value? In this example, I choosing the value of 1, 0, 0, 1, 1, 0, 1 is a data. In this data can be plotted in this position. This 1 is from 11, this 0 is from 0, this 0 is from 0, this 1 is from 7, this 1 is from 6, 1 is from 5, this 1 is from 3, other 1, 2, 4, 8 is already redundant. Now we are going to find the R1 value. How to find the R1 value? Already we are finding the XOR of 1, 3, 5, 7, 9, 11 is the R1 value calculations. Now we are finding this value. As already 1 is our redundant bit, that's why that can be eliminated for this R1 calculation. We are going to compare this 3, 5, 7, 9, 11 performing the XOR operation. In this position, 3 is containing the 1, 5 is containing the 0, 7 is containing the 1 and 9 is containing the 0, 11 is containing the 1. That's why the number of 1 becomes 3. This is R1. Here we are going to perform the XOR operation. That's why R1 value becomes 1. This 1 can be replaced by the R1 position. This is the calculation of the R1. As like that, we are going to find the R2 value. How to find the R2 value is XOR of 2, 3, 6, 7, 10, 11 is R2 is already a redundant bit. That's why 3, 6, 7, 10, 11 we are going to perform the XOR operation. That position is containing the 1. 6th position is containing the 1. 7th position is containing 1. 10th position is also 0 and 11th is also 1. Here number of 1 becomes 4, that is an even number. Here perform the XOR operation, that's why R2 value becomes 0. This 0 can be replaced for the R2 position. Then we are going to find the R4 value. The R4 value XOR of 4, 5, 6, 7. Here 5, 6, 7 is the grouping of the XOR operation. Here number of 1 becomes 2, that's why this is an even number. The R4 value becomes 0. This 0 can be replaced to here. Then R8 value. This R8 value we are going to perform the XOR operation of 9, 10, 11. This here contain number of 1 bit. Here number of 1 becomes 1. That's why this R8 becomes value becomes 1. It can be replaced here. This is the code word. Finally, we are getting the 11 bits, 7 data bits and 4 redundant bits. This 4 redundant bit figures 1, 0, 0, 1. The combination of redundant bit and the message bit is called as the code word. This is the code word. This code word can be transmitted from sender to receiver. During the transmission, this bit only to be changed for our example. How to detect the error and how to detect the position of the error also. In this side, we are going to finding the error detection in Hamming code. R1 is equal to XOR 1, 3, 5, 7, 9, 11 is already known to everyone. Now we are going to perform the XOR operation of these values. Here number of 1 becomes 1, 2, 3. That's why this is R number. That's why R1 value becomes 1. Then we are going to find R2 value XOR of 2, 3, 6, 7, 10, 11. We are going to XOR of this grouping. Here number of 1 becomes 1, 2, 3. Here is also odd number. That's why R2 value becomes 1. As like that, we are going to find the R4 value XOR of 4, 5, 6, 7. In this grouping, where the 4, 5, 6, 7, the number of 1 becomes 1. That's why R4 value is also 1. Next, we are going to find the R8 value. We are going to perform the XOR of 8, 9, 10, 11. 8, 9, 10, 11. Here, this number of 1 becomes 2. This is an even number. That's why R8 value becomes 0. This is used to help to finding the position of the error. What is the value of this binary number? This is a 7. The bit in position 7 is in error. This is the Hamming code. It can be detecting the single bit error. In our data transmission, the 7th bit is the error. In the transmission, 7th position is the error. 1, 2, 3, 4, 5, 6, 7. The 7th bit, the 7th position is only changing from 1 to 0. Thank you.